Hello students, this lecture is on design of experiments. We're going to learn about how to set up a good controlled experiment by asking ourselves what's called a testable question. So our first objective is to be able to write a testable question based on something we want to find out. And we're also going to learn how to identify different types of scientific variables for our experiment. In this case, the independent, dependent, and control variables for an experiment. Okay, let's talk about what a testable question is. Now, if we want to do a controlled experiment, that means an experiment where we actually set up what we want to find and change something in a very controlled way and then see the results, we want to ask a testable question. And the example that I have here is not the only way you could formulate a testable question, but it's a way that's going to help us learn how to make good testable questions. So let's try good experiments starting with a testable question of the form, how does blank affect blank? You know, if I ask a question, I wonder how long it takes me to get to work. That's not really a testable question in the sense that I couldn't set up a controlled experiment about it. Now, if I ask the question, I wonder how the time I leave my apartment affects how long it takes me to get to work, that is a testable question. I have something up here that I'm looking for the effect of the time I leave my apartment, and I'm trying to see its effect on something else, which is over here, the time it takes me to get to work. So that would be an example of a testable question. Right here, how does the time I leave my apartment affect how fast I get to school? We can make our best guess at answering the testable question by formulating a hypothesis. So a hypothesis is our best guess at the answer to the testable question. And this is before we conduct an experiment. We're trying to see what is our prediction for what we will see in the data. We're going to be talking about several scientific variables. Variable means many different things in a few different subjects. For science, we're going to define it as anything for which we can clearly distinguish different states or amounts. Basically, if there's something I can measure, it can be a variable. For example, temperature can be a variable because I don't have to say it's hot in here. I can say it is 87 degrees in this room. There's something I can measure about it. I could measure my mass, I could measure my weight, my height, I could measure the dimensions of a box, I could measure the volume of a container in milliliters or gallons or what have you. If it's something that I can measure in an amount or show different states for, like on, off, something like that, it can be a variable. There are several specific kinds of variables in science. One is called the independent variable, and that is a variable that we are going to intentionally change in order to observe its effect on a system. And in my previous example, that would have been the time I leave my apartment. If we go back to the testable question I posed, how does the time I leave my apartment affect how fast I get to school? This right here, this first blank, the time I leave my apartment, that is the independent variable right there. That's what I'm going to change. I might try out different times. I could leave at 6 o'clock, 6:15, 6:30, 6:45, and then measure how fast I get to school, which is going to be my dependent variable. That's a variable that we observe for any effects that might help us answer the testable question. Example would be time I left apartment. And later on when we get to graphing things, we're going to learn that we always want to put this variable on the x-axis. And we'll see some examples of that in a later lecture. But my dependent variable, the example that I gave was how fast I get to school. Okay, and that we're going to want to put on the y-axis whenever we graph it. So I'm looking for the effect of the independent variable on the dependent variable. How does time I left my apartment affect how fast I get to school? Now when I have my independent and dependent variable, I want to make sure that I keep certain other things constant, and we call that a control variable. Usually this means everything else that's related to it. For example, I would not want to change the route I take to school if I'm doing this test. If I left at different times and then measured how long it took me to get to school, but then every time I did that I took a different route to get to school, I'm not really checking for the answer to this question, because the route could make a difference. In fact, it probably does. So I would be seeing some effect on my dependent variable that is not due to my independent variable. I don't want that. So I'm going to try and keep everything else as constant as possible from time to time. My question too is, why is it important to keep all other variables constant? So what I'd like you to do is pause the video, answer this question in your notes as a stop to think. Okay, hopefully you've written your answer down. One possible answer to this is that we don't want any effects from variables besides the independent variable. This would result, we may not be actually able to answer our testable question. We may not be able to conclude anything about our testable question. Okay, again, if I change the route that I took to school every time I tried to leave my apartment, I wouldn't really be testing for the effect of time I left the apartment. There would be this other effect added in there. So that's why we want to keep control variables constant. So let's take some examples and see if we can identify a testable question, some independent variables, and dependent variables and control variables. So I have an example here. A major soft drink company is looking for a new spokesperson, but they're not sure who they want to hire. They've decided to try out a few different people on 500 cans each. With a picture of Drake, they sell 233 cans. With Jay-Z, they sell 424 cans. And with Lil Wayne, they sell 198 cans. Okay? I would like you to determine what is the testable question here, what is the independent variable, what is the dependent variable, and can you think of any control variables that we might want to have in this experiment? Okay? Pause the video and try out this example. Okay, let's see how you did. So, a testable question, remember, we want to ask a question of the form, how does blank affect blank? At least for now, that's going to help us make good testable questions. So in this case, there's a few different ways you could have written it. I would write, how does the artist on the front of a soda can affect how many cans are sold? That is a testable question. Okay, I'm looking for the effect of one thing, the artist on the front of a soda can. That is what I'm looking for the effect of. And I'm looking for its effect on how many cans are sold. So here, this right here is what I'm looking for the effect on. My independent variable is what I'm going to change every time, or what I'm looking for the effect of. It's the artist on the can. My dependent variable is going to be what I'm looking for the effect on. I'm looking for the effect on how many cans sold. Okay, that's the dependent variable. Did you think of any control variables that we would probably want to have on this experiment. I can think of few. There are many. There are many possible answers for control variables, but one I would say is keep the same kind of soda in each can. Why would I want to keep that constant? Because if Drake is always on the Coke cans, Jay-Z is always on the Sprite cans, and Lil Wayne is always on the orange soda cans, and you are a Coke person or a Sprite person, you're going to be choosing the soda based on what's in it, at least partially, as opposed to who's on the front. And we wouldn't actually be measuring the effect of the artist specifically on how many cans are sold. I might also want to keep constant size of the can. You know, if some cans are bigger than others, then maybe it doesn't matter. Maybe even though I like Jay-Z more than Drake, I might go for a bigger can that has Drake on it just because I want more soda. I wouldn't want that messing up my results. So same kind of soda. We want to keep the same size of the can. And we probably want to keep same placement on the store shelves. If I keep one kind of can at eye level and I keep another one way down on the floor by people's feet, maybe they're just not going to choose that can because they couldn't see it. So that's going to screw up my results. Okay, let's look at a second example. Okay, example number 2 is on the screen. Same thing, I'd like you to read the example. We're trying to formulate a testable question, an independent variable, a dependent variable, and any control variables that you can think of. I'd like you to pause the video now and see if you can come up with these statements. Okay, let's see how you did. In this case, we're looking at the effect of one thing on another to formulate our testable question, and we're looking for how does level of education affect unemployment rate? Okay, I'm looking for the effect of level of education, so that's going to be my independent variable. And by the way, even though this isn't necessarily a number, level of education, at least past high school, past grade 12, you can't necessarily put a number on it, but you can distinguish different states. Remember that a variable is anything that we can distinguish different states. I can clearly say that this is one option, this is another option, this is another option. In this case, level of education is graduate school. That's one state. Another state is finished college, another is high school degree, and not graduating high school. It is a variable. So dependent variable is unemployment rate. We're looking for the effect on employment rate. Okay. Any control variables that I should have, there could be many. Maybe I want to study people from the same area. The unemployment rate might be way higher in New York versus Boston, for example. And if you're looking at people from all over the place, then you may not actually be getting the effective level of education. Or maybe even like the same country. A college degree from France might mean different things than a college degree from the UK or the United States, for example. That could be one example of a control variable. It really depends on your study, what you might want to keep constant. But the key to thinking about it is, are there variables out there that I don't want their effect to confuse my results? And that's how you can define a control variable. So maybe another way of putting that would be make sure that levels of education are defined the same. Okay, does finished college mean the same thing for all those people? If it doesn't, I might get some strange results. I should probably make sure that unemployment is defined the same way. If I define unemployment as just temporarily out of a job, that's one thing. If I define unemployment as I've completely given up looking for a job because I'm never going to find one, then that's also something else. Okay? Here's example 3. Oops, up here, example 3. Same thing. You're going to read through the example. You're going to consider what we're actually trying to find out. Formulate a testable question. Identify the independent variable, dependent variable, and any potential control variables that you can think of. Pause the video now and try this example. Okay, let's see how you did. Juan wants to know what time of day is the hottest. He's checking his thermometer several times during the day, and he gets various results. Our testable question here is, how does the time of day affect the temperature? How does the time of day affect the temperature? Okay, so independent variable is what I'm looking for the effect of. I'm looking for the effect of time of day. So time of day. And I'm looking for the effect on temperature. How does time of day affect the temperature? I'll put that here, temperature. Okay, measured in degrees Celsius here, looks like. What are some control variables that we probably want to have in this experiment? Well, let's see. I should probably measure temperature in the same location each time. Because if I didn't, what if there's a hotter room in a building? And you all know my classroom is pretty hot, temperature-wise. So if we measured once in my classroom and then went all the way across the school to the cooler side of the school and made some measurements over there, that's going to screw up my data. I wouldn't actually be looking at the pure effect of time of day on temperature. I would be confounding my data. I would be confusing it with something else, the effect of location, which would be a different testable question. I probably want to use the same temperature scale and thermometer. What if thermometers are calibrated differently, or some of them are a little bit different than others? I may not be able to really tell what the answer to my testable question is. And if I wanted to get a really big picture, I maybe want to pick a specific time of year or a particular day, for example. I mean, if I did this experiment in the winter, maybe it's different than if I did the experiment in the height of summer. Okay, so that's it. Let's go back to our objectives. You should be able to write a testable question based on something we want to find out. So, hey, I want to know this. Can we phrase it in the form of a testable question? What is the effect of blank on blank? And then given a testable question or some sort of scenario where we want to do an experiment, you should be able to identify the independent, dependent, and control variables for that experiment.